Welcome to Eureka Math. I'm Mr. Shankel. I'm going to be helping you today with Module 1, Lesson 8. Let's get started. Okay, now that we know about positive and negative powers of 10, we can compare numbers and estimate how many times greater one quantity is compared to another. So let's do that in exercise 1. Here's our problem. The Federal Reserve states that the average household in January of 2013 had $7,122 in credit card debt. About how many times greater is the U.S. national debt, which is a big number. Let's see, millions, billions, 16,755,133,009,522. And we're going to rewrite each number to the nearest power of 10 that exceeds it, and then compare. So we're going to do what we did in our last lesson, find the next power of 10 that exceeds our number, and compare that way. So let's start with the average household debt, which was $7,122. Ooh, that's a crazy one. Okay, $7,122. And remember, we said that that's just a little bit less than the biggest four-digit number, which would be 9,999. And then we could say, well, one bigger than that would be, the next power of 10 would be 10,000. So 10,000, and that is equal to 10 to the fourth power. Okay, so 10 to the fourth power is our average household debt. And then we'll do the same with our U.S. debt. Let me get a different color here so we can see the difference. So we've got that big number. Well, if I were to rewrite that 16 trillion, I wrote it as the biggest possible number with that many digits, which would be 14 digits, 3, 6, 9, 12, 14 digits. So this would be 9, 9, another 9, another 9, another 9, and just keep right until I have 14 digits. That's 8, and there's 11, and then 3 more 9s. Okay, so I would have that 99,999,999,999,999, and we know that that is just a little bit smaller than our next power of 10, which instead of 14 digits would be 15 digits. So this would be 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 digits. And that is going to be 10 to the 14th. So this is equal to 10 to the 14th approximately. And then we can compare. We can take our 10 to the 14th, which is the U.S. debt. Let me just put U.S. over here so we know. 10 to the 14th over our average household, which we said would be approximately 10 to the 4th. And then we can use what we know about exponents, and we could rewrite this as 10 to the 14 minus 4, which is 10 to the 10th power. So when we compare the U.S. national debt to the average household debt, the U.S. debt is 10 to the 10th times bigger than the average household debt. Okay, so we're just taking what we've learned in the previous lesson and now comparing and using what we know about exponents to compare our two situations. Okay, exercise 2. There are about 3 million students attending school, kindergarten through grade 12 in New York. Express the number of students as a single-digit integer times the power of 10. So here is our 3 million number, and I wrote it this way to kind of demonstrate how we're going to change this from a number 3 million into scientific notation. So we have a decimal here at the end. That's 3 million. And in order to make this into scientific notation, I want my decimal to be there, right behind the first digit. So this is going to be 3. This is equal to 3 times 10 to some power. And the way to find that power is to move this decimal 1, 2, 3, 4, 5, 6 places 6 places, and that it means I'm going to have 3 times 10 to the 6th power. So there I've written a single-digit integer. Single-digit integer is my 3 times a power of 10. So there's my power of 10. So it's 3 times 10 to the 6th power. Okay, and then the average number of students attending middle school in New York is 8 times 10 to the 2nd power. How many times greater is the overall number of K through 12 students, which was this, K through 12 was this, compared to the average number of middle school students, which was this? So we're going to compare those two. We're going to compare 3 times 10 to the 6th to our middle school, which is 8 times 10 to the 2nd power. Okay, and then this is going to be middle school in the purple, and in the green this was K through 12. So we just have an idea of what our numbers are. We remember that. Okay, so now let's see, the 3 and the 8. Well, I can't divide those, so I'm just going to leave those as 3/8. But I can do something here. This 10 to the 6th over 10 to the 12 we know is the same as 10 to the 6 minus 12, or sorry, 10 to the 6 minus 2, which would be 10 to the 4th. So this is 3/8 times 10 to the 4th power. And then we can think of 3/8 as, let's make that a decimal, let's make that 3 divided by 8 is 0.375 times 10 to the 4th. And then we can change this back, just the same way that we did earlier. We can change this back to a number without scientific notation by looking at our exponent. Well, the exponent is a 4, so we're going to move this decimal 4 places. 1, 2, 3, 4. That means a 0 gets added in that empty space. So it's 3,750 times greater, the number of K through 12 students compared to the middle school, 3,750 times more. All right, exercise 3. A conservative estimate of the number of stars in the universe is 6 times 10 to the 22nd power. The average human can see about 3,000 stars at night with his naked eye. About how many times more stars are there in the universe compared to the stars a human can actually see? Okay, so we're going to take our 6 times 10 to the 22nd power, and we'll write that down. And then we need to change this 3,000 stars into scientific notation. So I'm just going to show that over here. It's 3,000, the decimal is here. We need to move it 1, 2, 3 to get a single-digit integer, and that means we've moved it 3 places. So this is 3 times 10 to the 3rd power, and there's our comparison. And then we can do our simplifying. So let's take 6 divided by 3. I can do that's equal to 2 times 10 to something. Well, I've got a 22 and a 3, so I can subtract those since it's division. 22 minus 3 is 19. So this is 2 times 10 to the 19th power. And that would be the number of stars that we, that would be the amount of times more stars that are in the universe compared to what we can actually see. So 2 times 10 to the 19th. Now, if I were to write that out, that would be 2, and I would have to move my decimal, which is here, 19 places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 places. The decimal would go there, and then all of these empty spots here would be zeros. So there's zeros, that's a comma there, and then 1, 2, 3 more zeros, comma, 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 and another 0 there. So let's see, we've got, this is millions, billions, trillions, quadrillions, quintillions, 20 quintillion times more than we can see are actually out there. And you can see why scientific notation is preferable to writing out these large numbers with many place values. Okay, exercise 4. The estimated world population in 2011 was 7 times 10 to the 9th. Of the total population, 682 million of those people were left-handed. Approximately what percentage of the world population is left-handed according to the 2011 estimation? Okay, a couple things we have to do here. First of all, let's take this left-handed population, 682 million, and since they use the word approximately, we're gonna round that up to the next power of 10. So let's say that we've got instead of 682,000, we're going to say 682 million. We're going to say 700 million. So it's 700 million would be this number, and then we're going to write that as 7 times 10 to some power. So this is going to be 7 times 10 to some power. Well, again, remember, we're going to be moving our decimal, which is here. 1, 2, 3, 4, 5, 6, 7, 8 times. So this is going to be 7 times 10 to the 8th. And so let's go left-handed is 7 times 10 to the 8th power. And then we're going to have the world population. World population. So all people in the world. 7 times 10 to the 9th power. Okay, and then I wrote this in this order, left-handed compared to the world, because we want a percentage. And this will tell us the percentage by putting the smaller number on top out of the total. Will give us the percentage of the world population that's left-handed. Okay, so let's do this math then. 7 divided by 7, well, that's 1. And then we've got times 10 to something. Well, I've got an 8 minus 9. If I did it that way, it would be 8 minus 9. Well, that's equal to 1 times 10 to the negative 1. And then remember, a negative exponent we can write as the reciprocal, so that would be equal to 1 times 1 over 10 to the first power. And that's just 1/10, and 1 times 1/10 is 1/10. So 1/10 is the relationship of left-handed to the total world population, and then to get a percentage, that means per 100. So 1/10 is the same as 10%. So 10% of the world population would be left-handed. All right, very good. Exercise 5. In exercise 5, we have the average person takes about 30,000 breaths per day. Express that as a single-digit integer times the power of 10. So we're going to take this 30,000 and we're going to move the decimal 1, 2, 3, 4 places. So this is 3 times 10 to the 4th power. That's the number of breaths per day. And then if the average American lives 80 years, which is about 30,000 days, how many total breaths will a person take in her lifetime? So this time we are going to be multiplying these two numbers, because 30,000 breaths per day, which is for 80 years, which is about 30,000 days. So it's going to be 30,000 times 30,000, or 3 times 10 to the 4th times another 3 times 10 to the 4th. And we're going to multiply those two numbers together, which when we do that, we get 3 times 3. That's equal to 9. And then we're multiplying two bases. So this is times 10. So we're going to add these exponents. When we add those exponents, we get 9 times 10 to the 8th power, 9 times 10 to the 8th power. So if we were to expand this, we would need the 9, which has the decimal here, and then we have to move that 8 places. 1, 2, 3, 4, 5, 6, 7, 8 places. The decimal's now there, and these would be zeros. So if we fill in our zeros here, then we can say, let's see, let me use a different color so we can see comma there, and we have a comma here, so it would be 900 million breaths in a lifetime. All right, that is lesson 8. Hope that helps. We'll see you again next time.